Find the minimum and maximum distances between the ellipse and the origin. You don't have to graph exactly, but the graph looks like this. And let the generic point, any point on the ellipse, be xy, and then we can find the distance of this point xy from origin 0 0 by distance formula, which is root x square plus y square. Okay, that's our objective function. But instead of working on this square root, so let's take the function x square plus y square without square root, just to make our life easier. Okay, that's the objective function for now, and the constraint is just the ellipse. So the points x, y should satisfy this equation. So this is the constraint, it's given, and based on this we write gx, bringing this to the left side, just making this equals 0. So this is the g function. Now to use Lagrange multiplier, we have to calculate gradient f, which is f with respect to x and y. So just 2x 2y, and gradient g, which is 2x plus y, and here is now with respect to y x plus 4y. And then we set them equal. Gradient f equals lambda gradient g, that means 2x 2y equals lambda times 2x plus y x plus 4y. Distribute lambda inside, that gives us two equations now. 2x equals lambda times 2x plus y, and 2y equals lambda times x plus 4y. We have two equations, and the constraint itself, x square plus xy plus 2y square equals 1. That's the third equation. Now we need to solve these three equations to find x and y, this constraint and these two equations. Okay, so let's do that. Let's isolate lambda from here. Okay, if we isolate lambda from here, what we're gonna get from the first, lambda equals divide by 2x plus y, so 2x over 2x plus y. At the same time, lambda is 2y over x plus 4y, so this ratio will be same as 2y over x plus 4y. Okay, this is lambda, this is also lambda, so these two ratios are equal. Let's solve this. This fraction equals this fraction. On the top 2 we can divide both sides by 2, so we can cancel these two. Do not cancel any other thing. If we multiply this way, x square plus x times 4y 4xy equals this way 2xy plus y square. Let's bring everything to the left. X square 4xy minus 2xy plus 2xy. Okay, this is 2xy minus y square equals 0. The idea here is now express x in terms of y, or express y in terms of x. And once we have x and y, go back to the constraint and plug in. Okay, so let's isolate x. For x in two places, so you can use quadratic formula. At the same time, x square plus 2xy plus y square would have been x plus y square. So let me do that little algebra here. X square plus 2xy plus y square. I want to move this y square other side, and this is added here, this plus y square, so we have to add y square as well. This negative y square is moved. I added plus y square because then this is just x plus y quantity square, and adding y square both sides. So this is x plus y quantity square equals 2y square. take square root both sides. X plus y equals plus minus root 2y, and subtract y from both sides. X equals negative y plus minus root 2y. So x equals, finally we can factor y out, negative 1 plus minus root 2. Okay, so we have x equals 1, negative 1 plus minus root 2. Let me rewrite this one more time. Negative 1 plus minus root 2y. Now we plug this x value into the constraint, which is x square plus xy plus 2y square. Okay, and we get y value. Plug x equals negative 1 plus and minus, there are two values by the way, root 2y into the constraint. What is the constraint here? The constraint was x square plus xy plus 2y square equals 1. Okay, that means x is now negative 1 plus minus root 2 square y square. X square means plus x times y, so this times y, so negative 1 plus minus root 2 y times y square plus 2y square equals 1. Y square, y square, y square, we can combine y square, factor out, negative 1 plus minus root 2 square, this is a decimal number, plus negative 1 plus minus root 2, another decimal number, plus 2, because y square is factored out, equals 1. So this is just a decimal number. 1 divided by this decimal number is y square. So y square is equal to 1 over this decimal number. Okay, now we have to take positive ones and negative, so let me do that in my calculator. So first take plus sign in both, so 1 over, when we take plus sign, 2.5858, 2.5858, okay, putting plus and using calculator, and 1 over, if we take negative here, 5.42. Okay, that's what you get approximately. Then we get y, that implies y is now plus minus, take a square root of this, about 6.2, so approximately, and a square root of this, plus minus 0.43. Okay, so we got y values, and we took a square root a lot of times, and we don't know whether all these y values work, because we always get extraneous solution. Okay, when we take a square root, so we've done that a couple of times. Now if we go up and look at here, this is x, plug in these y values here, we get x value. Okay, then the x values are, we have to take positive ones and positive ones here, because we got two values here. Okay, and we got two values, so basically we are getting 4. So when we take positive, we get plus minus 0.26, positive here, taking plus and minus. Then y equals negative value, take y negative and plug in here, and plus minus, we get plus minus 1.5. Similarly, y equals is plus minus 0.43, plug in here, then we get plus minus 0.18, taking positive, and put negative here, plus minus 1.04. So there are, I don't know how many, plus minus 0.26, plus minus 0.62, plus minus 1.5, plus minus 0.62, and here plus minus 0.18, 0.43. There are so many, so we need to check if all of them work. Okay, that's a lot of work, but this one, this and this y, if we plug in to the ellipse, they are extraneous, so this is not good, this is not good. Okay, they don't work. So we have points now, thus we have those nice points. X, y are now plus and minus 0.26 and plus minus 0.62, and here x is plus minus 1.04 plus minus 43. Now we plug these into the objective function, in fact our function, and find the distance. Thus the distance x squared plus y squared, this distance d, we get there will be so many different distances, and looks like if we put this, because we have square, so plus or minus it will be the same, because square means, so this pair will, this xy, these xy give us the shortest distance, and this xy gives us the longest distance. Okay, so the maximum, looking at these are bigger numbers, so that will be square root of, plus or minus doesn't matter, because when we square it's going to be always positive, 0.43 square. Use your calculator, and minimum is coming from here, 0.26 square plus 0.62 square. Okay, let me calculate that. So we get here using calculator, that's 1.13 and 0.67. Okay, final